Greetings of the day. In this brief presentation, I'll be having a topic which is interesting and very useful for life in general and the examination in particular. I'll be correlating the concepts of longitude and time. You all know from your school days that longitude is the angular distance of a place east or west, and you know this distance is measured from what is called the prime meridian of the earth. And you also know from school days that Greenwich meridian is the prime meridian, the 0-degree meridian, which was adopted in late 19th century in the year 1884 in the conference named International Meridian Conference held in the city of Washington, D.C. Now, let me show you the place called Greenwich. Now, the question first would be that why this Greenwich meridian was chosen as the prime meridian in that conference. There are three reasons which are generally associated with this selection. First is that at the place called Greenwich, there is a royal observatory, and this is a building which was already in use as a reference by the sailors of the world and others. So this historical usage of it as a reference went in favor of the selection. Now see, this is that line in that building which is the prime meridian of the world. Now when I say Greenwich meridian, it means a line which joins North Pole with South Pole of the earth, passing through this place called Greenwich. And Greenwich is a small town little east of London. And this is the Royal Observatory. So this became the one reason, historically speaking. The second reason which is there in the selection of Greenwich meridian as a prime meridian relates to the dominance of the English Empire. And generally it is seen as an unstated reason that we generally don't mention about it, but it is understood. And the third reason for the selection was that this Greenwich meridian as the 0-degree meridian of the world gives us a very good choice or a convenient choice for what I'm going to teach you today as International Dateline. That is 180 degrees meridian. You know, on the spherical earth, from Greenwich meridian, we can move 180 degrees east or 180 degrees west. So let's suppose my left hand is a globe, and this is the North Pole and this is the South Pole here. If I join these two poles via the place called Greenwich, then I get Greenwich meridian. And since this is a reference meridian, so if I go on the east of it, means if I go from Greenwich close to London towards India and then towards Japan, I'm moving eastward. So maximum I can move on the east is 180 degrees east. And similarly, I can move from Greenwich towards North America, that would be westward journey, and I can reach to the same opposite side, but now I'll call it as 180 degrees west. It means if my right hand is a Greenwich meridian, I can move on the east and go extreme opposite, and that would be 180 degrees east. And similarly on the other side, 180 degrees west, it means basically longitude varies from 0 to 180 degrees east or west. And 180 degrees east or west is a very interesting meridian. It is very fascinating meridian because across this meridian, a traveler will find a change of a day on the calendar. Depending on the direction in which he or she crosses it, there is either a gain of a day or loss of a day. Now we'll see the details of it, but before we go to the details, just imagine if this date change, like if this international dateline is there in the densely populated areas of the world, then this would become a nuisance for the people. Perhaps people will keep jumping across the line to change their daily commitments. So the people who were there in that conference of 1884 in Washington, D.C., they were wise people. They could understand these problems, they could visualize these problems beforehand, before they selected this particular international meridian, which was to become the dateline of the world. So, they were looking for such a choice which should not disturb much of humanity. And they found that when you take the Greenwich meridian as your 0-degree meridian of the world, the opposite arc of it, which was to become international dateline, because you will see today 180 degrees becomes the international dateline. So, the opposite arc of Greenwich meridian give us a very convenient choice of IDL, international dateline, because opposite arc of Greenwich meridian is passing through the mid of the Pacific Ocean. And you know, in world ocean, we do not have much of population. So it was not a disturbance to much of the population except a few communities. And you know, when there's a problem for a few communities of the world, then you certainly can make certain adjustment for those particular communities as such. So that is what is done, and that is why we will find that there are certain deviations to this international dateline from the value of 180 degrees longitude. Now let's take this discussion more in a structured way. So first let me show you that if this is our globe, so this line is our 0-degree meridian, because it is the place Greenwich here, that is England, and from here we measure how many degrees you are on the east or west. As this angle is shown, there is an angle of 60 degrees here on the east. Now, this is another reflection of that. If I take this place as Greenwich, so this is your Greenwich meridian, this is your reference meridian called prime meridian or the 0-degree meridian, and if there is a point P on the earth surface, and this particular meridian is how many degrees away? Y degrees on the east again. Now, these are the three reasons which I have already mentioned, that today you will see the main reason which turned the tables in favor of Greenwich meridian as our 0-degree meridian was the third one, that it gave us a convenient choice of the line which was to become the international dateline, that is line across which there is a change of a day on the calendar. Now, let us first relate longitude with the concept of local time. You know, local time, as the name indicates, the time of a particular place. By that I mean, when I fix my watch in relation to the position of the sun in the sky, that particular time is called local time. And how do we fix the time vis-a-vis the sun's position in the sky? We know from school days that the best moment for this fixing is a 12 noon local time. You know, after the sunrise, as the day progresses, sun goes higher in the sky. And 12 noon local time is the moment of the day when the sun is highest in the sky. And how do I know that sun has reached highest for my place? That I can do, I put one object on the road outside and I wait for the moment when the shadow casted by that object is the shortest, making me understand that the angle of the inclination of the rays is maximum. And that particular moment when the shadow given by the object is the shortest, I can put in my watch as 12 noon local time. Now, if I take you historically here, Romans who came after Greeks in Europe, they were the ones who gave us the term meridian to indicate 12 noon local time. Meridian is a combination of two Latin roots. Meri in meridian means sun's highest position, and dian comes from dime, which means a day. It means meridian, that is 12 noon local time, is the moment of the day when the sun has reached highest in the sky. Now, the term which is given by the Romans is still used worldwide. When we say AM, anti-meridian, that is before noon, and post-meridian, that is afternoon. Now, if you have understood the concept of local time, let's now bring some numerical part in it. Imagine a small globe in my left hand. As Earth spins, in one spin of the Earth, 360 degrees of longitude get covered. So I can equate 360 degrees of angle of longitude to 24 hours a time. When I simplify this relationship, I would get 1 degree of longitude suggesting a time difference of 4 minutes. Means those places which are separated by 1 degree of longitudinal distance, they would have a difference of local time for 4 minutes. And you know, when you have difference of time, then there is one of the two possibilities that you are talking about a place either ahead of the other or behind. So to understand that point, let's bring the direction issue also. You know, Earth spins eastward. So those places which are on the east of a given point, they are ahead in time, because places on the east would have the sunrise earlier and places on the west would have sunrise later. For example, I can say New Zealanders, Australians, Japanese, being on the east of Indians, they are ahead in time. And Americans are on the west of Indians, it means they are behind. So, east you are ahead and west you are behind. Now, let us see some calculation part here. So, see, this is the way the earth is rotating, west to east. Now, if we are given the local time of a particular place and we are asked to find out the local time of some other place of the world on the east or west of the given place, then we can do it this way. Let's suppose that there is a place A and I am given the local time of this place as TA. And my question says that when it is time T at A, find out the local time at B, which is a place on the east of A. Now, I know 1 degree of longitudinal difference stands for 4 minutes of time difference. So my first step would be to find out how many degrees of longitudinal difference is there between place A and B. Let us suppose in this diagrammatic presentation, it is x degrees. 1 degree stands for 4 minutes. So I multiply this x degree by 4. I'll get those many minutes, x multiplied by 4, this much of time difference in minutes between A and the time of B. Now I convert this time difference of minutes into hours and minutes. I'll check how many complete hours I can make out of the total minutes, and if there is a remainder, I'll keep it as minutes only. And now I'll go for reasoning that east, the place had seen the sunrise earlier. It means the people at B are ahead of the people at A. Ahead means they have already lived the time what someone is living at A now. So since they are ahead, so I would add this time difference which is there to the time of place A. It means the time for B would be time at A plus the time difference. And this is how we calculate the time for a particular place on the east. If you are given again the time at A and you are asked to find out the local time for a place on the west of A, then again first step remains the same, that you check how many degrees of longitudes are there between A and C. 1 degree stands for 4 minutes. You multiply that longitudinal difference by 4. So many minutes, y multiplied by 4 would be the time difference. You convert that into hours and minutes. And since on the west, since you know the earth is rotating eastward, so on the west you are behind. Behind means a person who is at C in this sketch is yet to live the time what a person lives at A. Yet to live means he or she is behind. Behind means you have to go back on time, means you have to subtract. So rule is on the west you are behind, so you need to subtract. So how do I find the time at C? Time at C would be equal to time at A minus the time difference which I get from this calculation. So this is how we find local time. Now, let us move to the modern concept, what is called standard time. See here, local time is convenient as a tool of human interactions till those times when societies were much smaller in size in comparison to what they are today. When a community is there over a small territorial extent in terms of longitudes, then local time is good for human interactions because the longitudinal extent is not much, so there is not much of difference because 1 degree only stands for 4 minutes. But if the country size or a community's spread over a particular area is over number of longitudinal degrees, then more you go from one extreme to the other, there will be significant differences. Imagine what if India follows local time at each longitude, then you certainly cannot have that ease in communication, or those things which are of national importance, they would certainly not be discussed that easily. Or think of holding of the online classes would not be possible because time differs from one place to the other. So, with the railways, with the telegraph lines, and the community spreading over larger territories, we had a need felt that we must switch over from local time concept to something which is more convenient. And what is something convenient? When in a longitudinal zone or in a country, instead of using local time, you start using some common time. So, what is standard time? Simple. That if this is a particular longitudinal extent, let's say this is the easternmost meridian and this is westernmost meridian, instead of going for local time which varies from one meridian to the other, what we do is we adopt the local time of one meridian as a common time for the whole country. So when you follow a common uniform time in a particular longitudinal zone, that time is called as standard time. And that longitude zone where you are using one common particular time is called as time zone. Now, for example, India is one time zone at present. Now, when you are fixing for the whole country or a longitudinal zone of the country one common time, then the first thing the country has to do is it has to choose one particular meridian which becomes the basis for that common time. So the meridian on which your standard time is based, the common time is based, is called standard meridian. For example, you know, we Indians have standard time based on 82.5 degrees east meridian. Now, common sense says that when you are choosing the standard meridian for the country's standard time, the ideal is that that meridian on which you set your common watch should be somewhere in the central portion. I'm not saying it should be the exact center, it should be somewhere in the central region. So we Indians have 82.5 degrees east as our standard meridian. One, for the reason it is quite central, and second, it has a close proximity to an important place, culturally important place, earlier called Allahabad and today Prayagraj. And this other reason for the selection of 82.5 is that 82.5 degrees east is such a value which is exactly divisible by 7.5 degrees. You know, we have taken Greenwich meridian as our reference meridian for the whole world, and the local time of Greenwich meridian is taken as the reference for the whole world. So any area which is on the east of Greenwich meridian would have time which is ahead of the Greenwich mean time, and on the west you are behind. So how much you are ahead, as we Indians are on the east, so how much would be IST ahead of the Greenwich mean time? That would depend upon which meridian we choose for our standardization of time. So we Indians have chosen 82.5 degrees as our standard meridian. One, it is central. Second, it has proximity to culturally important city of Allahabad, that is Prayagraj these days. And more so, the third reason is that this figure of 82.5 is exactly divisible by 7.5. 7.5 means 30 minutes of time difference. 1 degree for 4 minutes, 7.5 is for 30 minutes. So when you have such a divisibility, then from Greenwich mean time, which is the reference for the world, your IST, which is based on 82.5 degrees east, would be ahead in multiples of half an hour. So we have chosen this particular value so that we have this time difference of IST and Greenwich mean time in multiples of half an hour. If we would have chosen 81, 82 or 80 degrees or 83 or 84 degrees, the only problem would have been that our difference from Greenwich mean time would have been 5 hours and some odd minutes instead of the exact half an hour multiple as such. So this is about the selection of Indian Standard Time. So you understand the concept of standard meridian, time zone, and in the background you understand the countries which would be very large in longitudinal extent, they certainly would need to divide themselves into more than one time zone. because otherwise they will have practical problems because of extreme areas having too much of time difference. So countries like US, Russia today, or Australia or France, they are all gone for multiple time zones. And internationally, when we look at it, we find that the countries, when divide themselves into more than one time zone, the general rule followed is that they take 15 degrees of longitudinal extent as one time zone. It means between the two extremes, east and west, there would be maximum time difference of 15 degrees multiplied by 4. That is, in terms of time, it would be 1 hour's time difference, right? Now, in that conference of 1884, what in addition these scholars did was that they divided the whole world into 24 time zones also. Remember, one countries are going for their own standardization of time. The other, for any analysis of time for the whole world, they went for the division of the whole world into 24 time zones. And each time zone was kept as 15 degrees. So it means you can now think of two possibilities, that you are referring to some particular time in relation to a particular country, and or you are going for the concept of time in reference to the whole world as such. Now let's see how is this division done for the whole world into 24 time zones. These scholars of IMC, they started this division from the Greenwich meridian, that is 0 degree meridian. They took 7.5 degrees on the east of it and 7.5 degrees on the west of it. That gave them one time zone of 15 degrees. And thereafter, they went for taking the multiples of 15, like 15 degrees, 30 degrees, and so on and so forth, up to 180 degrees. And they took these multiples both on the east as well as on the west. And they declared these multiples of 15 on both the sides of the Greenwich meridian, east and west, as the standard meridians for the 23 other time zones. So it means we have 24 time zones of the world, one with the standard meridian of Greenwich meridian. By standard meridian, we mean the local time of 0 degree here is the common time under this global scheme for the entire zone, 7.5 degrees on the east and 7.5 degrees on the west of the Greenwich meridian. Same way, having taken 7.5 from the 0 degree, if I take 7.5 more, I reach 15 degrees. I declare this as the standard meridian for the next time zone. Means the local time of this is adopted as a common time for the next time zone. And I keep doing this on the east and on the west, and I get the whole world divided into 24 time zones. Now, you know, when I'm going east, I'm going ahead, and on the west, I'm going behind. So now, for any global reference, I can make an important structured kind of observation that when I move east, I'm moving east ahead at the rate of 1 hour per time zone. For example, if I switch over from this place to this place traveling eastward, on this place X, my watch is based on 0 degree under this global scheme. And when I shift to Y, my watch is supposed to be based on the local time of 15 degrees east, and these two watches would differ by 1 hour. So when I go east, I go ahead at the rate of 1 hour per time zone, and on the west, I go behind at the same rate. So this is the global scheme of 24 time zones. And now I take you to the most interesting concept of this discussion, and that is international dateline. Now you will see 180 degrees east or west becomes the fascinating meridian. Now see, visualize with me that if I open the globe into a sheet, means a sort of map, and put 0 degree meridian at the center, you find the one extreme on the east would be 180 degrees east, and on the other extreme it would be 180 degrees west. Now, through simple time calculations, 1 degree for 4 minutes time difference, and east you add and west you subtract, you will find that this calculation will make you understand that 180 degrees is a line across which there is going to be a change of day on the calendar. For example, if this is 6 p.m. Friday 26 January at the Greenwich meridian, and I find out the local time at 180 degrees east, you know there is 180 degrees of difference I multiply that by 4 as suggested earlier. I'll get 720 minutes of time difference. 720 minutes can be converted into 12 hours, and on the east you are ahead. So I add, as per earlier discussion, these 12 hours time difference with this time which is given to me at Greenwich Meridian. So when I go from 6 in the evening of 26 January, I add 12 hours, I get into 6 a.m. the next early morning, that is 27 January. And when I go on the west for such a calculation, there's a same time difference of 12 hours, but on the west you have to subtract. So it means you have to go behind. When you go from 6 p.m. in the evening by 12 hours, you reach early morning of the same day, that is 6 a.m. of 26 January. Now, let us understand how you will have the loss or gain of a day. Let us take this particular case which I marked on the sheet, that if you travel from Greenwich towards India towards Japan and you cross this particular line, this would be called as west to east crossing. Let's suppose you are here at place X and you are told time is 6 a.m. and date is 27 January. But the moment you cross, since the globe is round, you are here. Here means you are at this place Y, and you are told here it is 6 a.m. of 26 January. One moment back at X, you had 6 a.m. of 27 January and now it is 6 a.m. of 26 January. So when 27th January becomes 26th, when there is a decrease of a date on the calendar, remember, it is not a loss of a day, it's a gain of a day. When 27th becomes 26 January, you get a day to live once again in life. And that is what means gain of a day. That is, if there was an exam on 27th January and you thought a particular day is 27th January, but you are told the truth that it is 26th January, it means you get one full day to prepare for that exam again. That is the easiest way to understand. It's a gain of a day. Means decrease of a date is not a loss, it's a gain of a day. And the opposite direction, if you travel from east to west and cross this line, there would be a loss of a day. Now, so, as I said earlier, the Greenwich Meridian as 0 degree meridian gave us a very good choice for International Dateline. Because this International Dateline, which we get as the opposite arc of Greenwich Meridian, is passing through the mid of the Pacific Ocean without disturbing much of humanity. And wherever it was a problem, we happen to make adjustment. And you'll find now a historical context. See, though we set this particular international dateline in 1884 in that conference, but humanity had understood this change of time in the travel all over the or all around the world very early in history, and that was in the 16th century. 16th century you have heard of in your history books. Magellan, a great sailor, with his team traveled from Spain and went for circumnavigation. Though all members of that crew could not survive, but who reached back home after 3 years, they found that the records they had kept of their journey by the details of the local area where they reached back, they were not matching. There was a difference of 1 day between their records of the journey and the local date of their origin and destination finally in the return journey. So that gave them the first ever understanding that in circumnavigation of the whole world, there would be a change of a day on the calendar. So it means we got idea which today we see in a concrete way on the world map as International Dateline. Means it took a lot of time for this formal kind of thing to happen, that it happened in the late 19th century. So this is what I have written here. This was the first human experience with the time change on a global scale, the realization of which eventually led to the establishment of the International Dateline. Now, since you know, a day always begins at 12 midnight and 180 degrees east is the easternmost meridian of the world. So what is interesting for us to know is that International Dateline is that meridian of the world from where a new day begins on the earth. And it begins at 12 midnight. But after it begins, it will travel worldwide from east to west. Remember, there's an interesting generalization. As Earth turns eastward, the day would go westward. And since the whole world can be seen in 24 time zones, so I can say as Earth turns eastward, the day goes westward at the rate of 1 hour per time zone. So it means having started at 12 midnight at the International Dateline, the day goes westward at the rate of 1 hour per time zone, and in the next 24 hours, it will cover the whole world. But once 24 hours are covered, then this day would exit from where it started the earliest. For example, if you take my left hand as a globe and this line, this finger represents the line, the meridian 180 degrees here at the center. Now, here the day began, and with the Earth's rotation eastward, this day went westward. So if the day begins here at 12 midnight, after 1 hour, it will go to the next time zone in the west. After one more hour, it will go to the next time zone, and this is how it will cover the whole Earth. But after 24 hours, this day would exit from this time zone only. In the other time zones, the day started late. So here it started late by 1 hour. From here, the day would exit after 25th hour. From here, after 26th, and here after 27th hour. It means the rule becomes from the beginning of the day, I'd say, from the beginning of the day at 12 midnight at the International Dateline, first 24 hours the day travels the Earth, and then it exits from the Earth's surface, and the final exit of the day would be after 48 hours from the time of inception. It means there are 2 days, broadly speaking, on this Earth. The new day, which is in the process to cover the whole Earth, and the old day, which is in the process of an exit from the Earth's surface. Now, let me tell you one more interesting thing. That if you stand on the line called 180 degrees, what is the fate of that person who is standing on the line? If that is the question to me, then I'll say, theoretically speaking, standing on the line, you'll have both the days. For example, in my example, here it is that along 180 degrees, you will enjoy both 6 a.m. of Friday and 6 a.m. of Saturday as per my calculations of this sketch. That you have 6 a.m. Saturday and 6 a.m. Friday. You have both the moments being enjoyed, theoretically at least, at the International Dateline. Once you cross it, there would be a change of a day on the calendar. Now, another interesting thing is that when you cross IDL, you have a change of a day on the calendar. But remember an interesting observation, when you cross IDL, there is no change on the clock. Why would there not be a change on the clock? Because remember, we took multiples of 15 and the last multiple was 180, and these multiples were the standard meridians. So it means you need to remember that 180 degrees, which is our international meridian, that is the dateline, it is itself as it is the center of the time zone. So it means 7.5 degrees on both the sides of it make one time zone. And it means when you are in this particular time zone anywhere, you have no change in the watch, you have only a change of day on the calendar. Since the IDL is in the middle of a time zone, it's the standard meridian, so there is no change on the clock. Generally, many of the books miss this particular point. They only talk about the change of the calendar date, but they don't talk about the time. Time remains same on the watch on both the sides of the entire time zones as such, a time zone of this 180 degrees central meridian or standard meridian. Now, let me show you one important point in terms of the deviations this line has. I have mentioned here that since this 180 degrees meridian can cause some problems to the communities of the world which are living in the Pacific Ocean, and there could be some geopolitical issues also. So let me show you, and this you can explore in detail in your atlas, that you will find that this international dateline theoretically runs along 180 degrees meridian, but at certain places they had to make certain deviations. For example, you'll find that Aleutian Islands of Alaska have been kept on one side of the line so that they have one particular day, that is, they have no confusion, because if some islands of Alaska, some Aleutian Islands are on one side and the others are on the other side of the line, then there would be always a confusion for daily life as well as some military operations, etc. So for geopolitical reasons, America wanted that in the Bering Sea, all Aleutian Islands would be or should be kept on the same side of the line. and that has been ensured. Then you will find there are some communities in the South Pacific Ocean, like Fiji, Tonga, etc. They have a number of small islands in which they live. If some of their islands are on one side and the others are on the other side of the line, again their daily life would be full of problems. So for communities like Fiji, Tonga, etc., we have some deviations of this line from the value of 180 degrees meridian. Similarly, you find there's a huge deviation for the islands which make, I'll say, Kiribati. Now, spelling of that is Kiribati, but correct pronunciation is. So, Kiribati Islands have been given a deviation for this kind of same accommodation over the day. So, you will need to see three major deviations. One for the Aleutian Islands of Alaska. They have been kept for geopolitical reasons on the same side. And then second, I said Kiribati. And third, that those small communities like Fiji, Tonga, etc., they are kept for their convenience, that all of their islands are put on the same side of the line. Now, you will find this sketch, this map showing the 24 time zones. And you know, time zones are more for a global scheme. But whenever these time zones of 15 degrees each, with 7.5 degrees on each side of the standard meridian, whenever they are in conflict with the particular country's standard time, then you know primacy is given to the particular country's norms about the time. So you will find in this map there are certain deviations to those 50 degree zones. So my understanding is this, that in the international waters, the time zones of 15 degrees are kept exactly with the norms of 7.5 degrees on each side of the standard meridian. But when we come to the continents, these divisions have been given certain deviations to suit the political, economic and social constraints of these countries, because they have all these sovereign reasons to decide their own norms about their standard time. So we have covered an interesting topic of international dateline. The dateline means the meridian where there is a change of a day on the calendar, and this is the line from where a new day begins and an old day would exit from the Earth's surface finally. And then I would now like to stop in this presentation. I believe this gave you some basic insights about the relationship of longitude and time. Thank you very much. Take care.